So, Jasmine just asked, do we have any homework tonight? The lab that you're doing, whatever you don't get done with that will be part of your homework. But yeah, but it's not a lab in the traditional sense, and you'll see that, and I'll explain that in a little bit too. Okay. So, questions about logistics before we get started? Anything that I can answer for you about any of these pieces? Yeah. I will not be here after school today. I will be here. I will be here during Liberty Time today. I'll be here 7th period, but I have to run right after school to a meeting. So I can, answer questions for you any other time like that. So if you need it. Okay? All right. So first things first, going over homework. Are there questions that you have from the homework that you would like to discuss? Henry does have questions.
How do you find B for number 26?
Because I have number 26 memorized. I'll look. Hold on just a second. I just didn't have it out yet. Let's look. This is chapter 3. You guys don't have books with you. I'm sorry. Most of you don't. What number did you say, my friend?
26, letter B. I got A.
So question 26B. Sure. Let's look at it. So for those of you that don't have this right in front of you, the chatter is super distracting to me, so if you could tone it down, I'd appreciate it. Oh, at a football game, there's a T-shirt gun fired. So, well, never mind. I won't tell you about that right now. We'll talk about it later. The gun is fired at an angle of 40 degrees from the horizontal with an initial speed of 28 meters per second. The fan is sitting 60 meters horizontally from the gun, but high up in the stands and catches the T-shirt. So A, you said was okay? Is that true? But B?
We just find both.
I mean, we can. I'm asking. Yes? Okay. So, yes, let's just take a look at it. So we're doing, just to be clear, this is question 26. So let's draw ourselves a picture, shall we? Oh, I'm still frozen, so you can't see all my pretty Q26. There you go. All right. So there's the T-shirt gun. It's being launched. And this is where the fan catches it, somewhere up here, right? Does that make sense? So this one's a little bit funny because we haven't done one like this yet, have we? Yeah. Is that okay? Ian, you're looking a little bit perplexed by my picture. Is that okay-ish?
Yeah.
Okay. Let's kind of read it again. So at a football game, an air gun fires a T-shirt into the crowd. The gun is fired at an angle of 40 degrees. So this is my initial 40. Bless you. Speed of 28 meters per second. I'm just trying to kind of get this all in my head. A fan who is sitting 60 meters horizontally from the gun, but up in the air, it says, catches it. So we're going to go ahead and write out. So this distance here is 60 meters. And then it says, how long does it take, et cetera, and how high up is he? Okay. So it's really important when you're doing problems like this to get a mental picture of what's going on, which is why, remember, in our guess method, we have the P at the beginning, that silent P that is for picture. So we're going to draw a picture first. So that gives us a kind of our picture. And then we've got the height here. That's going to be like our dy, right? So far, so good? Let's write out our givens chart that we know and love. dx, vx, ax, dy, vy, ay, and the thing that ties it all together is the time. Okay. Help me out. I've got 7 things that need to be filled in. What you got first?
AY is negative 9.81.
Indeed. Woo.
Attaboy, Henry.
All right. Henry's down. What else we got? Other people. Share the love, share the fun. Nick, your enthusiasm is just like emanating from you. What you got? DX is 60. Fantastic. 2 down, some more to go. Yeah.
AX is 0.
Indeed.
That's another one.
Hi. Thank you. Okay. What else do we know? We got 1, 2, 3, 4 things left. Henry, I just want to share the fun, so I want to see if anybody else can help us out. Is that okay?
Yeah.
Yeah?
You
Go for it.
Vx is 28 cosine.
Where did you get that from?
Trigonometry.
Trigonometry, he says. I used my trigonometry. Just want to make sure this makes sense. So we did this a little bit yesterday, but just to make sure you're good, right? You said X, is that right? Yeah? That you were talking about Vx? Okay, I just want to make sure that I was doing the one that you were talking about. So there's Vx, right? And we can go this way with Vy. And then we've got our nice little triangle. We feeling okay with that idea?
Yeah.
Okay, so you got, this is your adjacent hypotenuse is cosine. That's where you got the cosine from. So I'm just going to write that in. Oop, hello, there we go. So we've got VI, so that was 28 times the cosine of 40 degrees. That's what you said, right? Okay, I just want to make sure that I'm saying what you were saying. And then VY, can anybody tell me what VY is going to be? Using the same thought process. Got the same hands. Go Abhishek, what you got? Awesome. Now I want to make sure, because we kind of went through that fast yesterday. Is that okay with people? I feel like we're okay with components, but I just don't want to leave anybody in the dust. Yeah? Okay, so we got everything here except the two things that they're asking for. So we're pretty well set, I think. We've got D, V, A, and we're looking for T in part A. So what equation am I going to use to find time? I hear mumbling. Does the mumbling match this?
Yes.
Yeah? Because that's the equation you're going to use almost every time you do a projectile motion problem.
Every time.
Yeah, I mean, now and then there are ones that don't quite match that, but most of the time this is what you're going to use, which is why our given list looks like that. Anything go to 0 in this one? Yeah, what goes to 0, Kate?
Hold on, I don't remember.
That's okay.
AX.
AX, 0 times anything is?
0.
So this whole thing goes to 0. That makes it pretty easy to find time then, doesn't it? Sure thing. So time is just going to be, what, dx over vx. So that's going to be 60 over 28 cosine 40. Somebody's got a calculator out. I can hear it clicking. It's a multiple choice question. Sometimes you're like, sweet, it's multiple choice. Oh, wait, I still have to do a bunch of stuff. Don't I?
Or just guess.
Or just guess. You got a 1 in 4 shot.
25%.
Except if it's a multiple choice question on one of Carbling's tests, since I make you actually explain.
Then
Then you might want to do it. Yeah, so there is that too. All right, so did we get a number? Did we get an answer?
Yeah.
Yeah?
What would you do?
Oh, they said 3 something.
So you guys agree? 2.8? That's letter C, so that's cool. Oops, not meters. Hello. Time is in seconds. All right. So then part B, which is really what you asked about at the beginning, didn't you? Sorry about that. So that was dy. You want to know dy. How do you do that? Same thing, right? Just use the y's. You know time now. She was going to use the y's to find dy. It was worded differently?
Yeah, so I thought it was different.
Yeah. But really, it's not. It's just kind of sneaky like that, isn't it?
Got it.
Nothing goes to 0. So that's kind of an important thing. Nothing goes to 0, so you have to just like plug stuff in, but it's already solved for dy, so just plug it in. So Henry, does that get you where you need to go?
What were the answers in multiple choice?
The multiple choice answers: 3.2 meters, 4.3 meters, 6.6 meters, 9.2 meters, and 12 meters.
We go over it then.
Sure.
I got 88.9 meters.
Did you have a negative 9.8? And maybe did you not square your time? That's what I'm going to guess. Is that you didn't make it negative and you didn't square your time. Double check it and see.
I'm trying.
While he's doing that double check, are there any others of these problems that you would like to go through?
I had question
I'm not going anywhere.
28. That was the last one I had a problem with.
Question 28. Okay. I'll take a peek at it. I'm going to read question 28 out loud while we're still doing this too. We're just kind of multitasking here. So a football is kicked at an angle of 30 degrees with a speed of 20 meters per second. How long will the ball stay in the air? I think if you can do 26, we can probably handle 28, but I can go through it if you want me to write it out. Would you like me to write it out, Henry, or no?
One more time, sorry.
No, you're okay. I'm asking you to do so many things at once. I apologize.
Darn it. I didn't use the negative for the acceleration. My bad.
There you go. Now you're happy? You're good now? Is that okay?
Yeah.
Okay, cool. So 28 is very similar to this, except that it's going to go all the way back down. So dy is 0. And then you're just going to plug in to find time. I'm super happy to go through it if you want me to, though. Would you like me to go through it?
All right, no, I think I did that.
Okay.
10.
Anything else on homework? Yes, ma'am. Sure. 8 is good. 8 is kind of a thinker problem. Kibby's going to be excited about 8. I didn't put it in there just because you were coming in, but when I read it, I was like, hey. All right. So here's the question. If you kick a football, at what angle to the ground should you kick the ball for a maximum range? That is, the distance down the field. And at what angle should you kick the ball to get a maximum hang time? That is, maximum time in the air. So can I ask real quick, for that one, was it kind of the whole thing that seemed scary, or is there a piece of it that I can chew on? And it can be just everything. That's fine, too. Okay, sure. So this is question 8. How many of you, and I'd like you to be honest, how many of you went through this problem and actually got it and it made sense to you? Okay, cool. I was curious. This one is kind of deep, and you got to know some trig to do it, but we'll do it anyway because it's fun. We're just going to look at it. It'll be good. All right. So it goes up and comes back down. We're paying attention to theta. I'm going to put a time limit on this because I do need to make sure that we do some other things. So we're going to do this. We're going to work on this for about 5 minutes and chew on it and talk about the approach. If we don't get to an answer, I'm going to make that okay. This problem is kind of a deep thinking problem. And while I want you to know how to maximize stuff, I also don't want you to get caught up in the details of it. Okay? This is a problem that is more computationally something than I would expect you to do on a test. So I just want to put that out there because I want to make sure that we move on. So the question is, what angle is going to give you the furthest distance? And what angle is going to give you the longest time? I'm going to do the longest time part first. Okay? Let's talk about that angle. Every time I launch at an angle, what part of it dictates how long it's going to be in the air? The y part, right? The higher the velocity in the y direction, the longer it's in the air. Does that make sense? Okay. So if I want to maximize the time, what angle theta do I want to launch at? What angle? 90. I want to launch it straight up. Now, those of my friends that play or watch football know that we're not usually going to kick something straight up in the air. But if we're answering the question, literally, how are we going to get the longest time in the air? We're going to kick it straight up in the air. Okay? So that's part B, or the second part of the question. That's the easier of the two parts. The second part, or the other part, I should say, asks us to maximize this distance dx. Okay? So without writing all of our givens out, let's just write out how you would solve for dx. That's the big long equation, right? dx equals vxt plus 1/2 ax t squared. What's the acceleration in the x direction? 0. Oh, that's nice.
We like that.
We like that. So now dx is pretty easy. So we have to talk about how to maximize something. In mathematics, how many of you guys have done like finding maxima? A few of you? And some of you are like, oh, maybe, I don't know. So if you're going to maximize this, and you've just got two things that you're multiplying together, to get this to be the biggest, you want to get either this to be biggest or this to be biggest. Does that make sense? Is that okay? Yeah. Or you want them both to be big. So if we know, because we did it before, that Vx is just Vi times the cosine of theta. then I'm going to write times t. I can't change VI. All I want to change is either theta or time. If I change the theta, is the time going to change? For sure it is, because that's what I figured out in the first part, right? So I need to find another way to talk about time. Enter the y stuff. Here we go. You ready? Here it comes. Your enthusiasm is just coming out. I can see it. I can hear it. dy equals vyt plus 1/2 ay t squared. If that ball goes all the way up and comes all the way back down, tell me the dy. 0. We're going to be good mathematicians because there's another mathematician in the room today. So I'm going to factor out my time. So Vy plus 1/2 Ayt. Is that okay? So either I'm going to get a displacement of 0 when time is 0. We don't care about that. Or when this whole thing is 0. You with me there? Okay. So I'm going to start my stopwatch here. Oh, there's no displacement in the y. Or I can look over here and there's been some displacement in the x, but not in the y. That's what I care about. So now I'm going to take this and I'm going to set that equal to 0. Okay? 0 equals Vy. Oh, well, I'll write it that. That's okay. 1/2 Ayt. Have I done anything really scary yet? I'm pretty much just doing the same thing I did without numbers. In order to make this thing as big as possible, I need to either get this one big or this one big. This has a thing in terms of t. I'm going to solve this for t. Can you solve that for t? Oh, yes, Miss Cobley, I can. Yeah? Help me out. What is t going to be equal to? Over what? You guys agree with him? No? Oh, yeah, and Vy is just Vi times the sine of theta over 1/2 Ay. Hey, the negative up there and the negative here are going to cancel because I want a positive time, right? Negative times don't make any sense. Okay. Hold on to your hats. Are you ready? Got him? You've got a hat on. Hold on. Just give me a look. He's like, seriously? Seriously? All right. Here we go, Ian. Hold on. Here it comes. Wow. There's some enthusiasm. It really makes me happy. Oops. We okay? Yeah? It's math. Woo! VI is not going to change. We're just going to leave the VI there. AY is not going to change. I didn't because the negative here, the AY is negative also. So yeah, because time has to be positive. Yeah, so I just kind of waved my hands. You disagreeing with me or with somebody back there? Oh, with Rudy? Okay. Well, there's
the answer before you even put the question on the boards.
Cool, because it's not that hard to figure it out. I mean, really.
You just drew the picture.
All right. Who hearts trig identities? How many people have that shirt? I heart trig identities, right?
Yeah.
Yeah, I know you have that shirt in your closet. You only wear it on Supermath Spirit Days, but you have it in your head. Okay, you ready? Sine theta, cosine theta. What is it? What is it? What is it? Anybody? Anybody?
Tangent squared.
Remember, you were supposed to. No, Lexi, you were going to say it out loud. We looked it up yesterday when we were doing the problem because I couldn't remember either. No, it's sine 2 theta is what it is, actually. Yeah.
Oh, yeah.
You're so stupid, Harrison.
No.
No.
It's sarcasm.
Kindness. But you know what? Here's the thing. Is that he probably knows that, but he might not. And you know what?
Harrison, I'm sorry.
There you go. Thank you.
I'm sorry, Harrison.
All right, Rudy.
Where
Where is sine 2 theta going to be a maximum?
45.
45, right? Shh. Because we all know the unit circle, and we know that sine of 90 is 1, right?
Yeah.
Yeah? So 90 divided by 2 is 45, okay? To get the maximum distance, you kick it at 45 degrees. There you go.
Nice humor.
Look at us doing physics. Woo, that was awesome. I love it. I love it. Thanks for asking, Kate. I appreciate that. Are you going to have to do it on the quiz tomorrow? No. But was it fun to do? For sure it was. All right. I heart trigonometric identities. Those are my favorites. All right, Harrison.
No, he literally.
I know, because he's awesome.
Before the question came.
I know, because he read his homework last night.
You did pass my.
Looks I only have 3. Harrison, you better get out. Sit down. What's with you?
Jacob.
Oh, Jacob's going to do
Oh,
it.
you did?
Because once you prove it once and you just keep it in your head, right?
Oh, because he no, he literally can't. Does he argue? Does he know his work? If I get water, what's above me?
I did not know that.
I'm not.
All right. Thank you, Jacob. I appreciate that. Did everybody get one? Okay, ladies and gentlemen. Yeah. Yeah, I'm sorry. I thought there were enough, but I must have got one stuck. Sorry, Elizabeth. All right. So I had hoped, my goal was that we were going to do this really awesome lab activity today where we did this video analysis, which I love and is so much fun. But the tech side of things was not working, and I'm really sad about that, and I've been trying, but it doesn't work. So I've got an alternative, and the alternative is pretty cool, but it's not quite as great, but I hope that you like it enough. And it will give you some practice and some prep for tomorrow, which is what we really care about. So, I don't know if you guys have ever used the PhET simulations before, like if you did this in chemistry or any other time, but there's a set of simulations that are online from a blah, 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 people do stuff. Anyway, on this website, and the website is also on Canvas, I'm going to show you that in just a second, okay? You are going to go, actually, I'm going to show it to you right now, and then you can see what it looks like. So when you go to Canvas, oops, excuse me, there we go. Under Unit 2C, Projectile Motion, hopefully this will work. It'll open up this simulator, and you'll click on here, and you see these cute little cannons and things, and they're going to launch things. And it's going to be super fun, and you're going to like it. Like, it's pretty good. So the thing that I need you to know is what you are going to work on, okay? And as Jasmine asked earlier today, do we have homework for today? The deal is that if you don't get this done in class, then you do it for homework because you have access to all this the whole time because it's all online. Does that make sense? So what I need for you to do, first of all, is to take an opportunity to familiarize yourself with the simulation. There are so many things you can change. You can change the object that you launch. You can change the air resistance. You can change the height. You can change the initial velocity. You can change the angle. There are probably about 7 or 8 other things that I can't remember. There are tons of things that you can change. So you're going to do that first. Listen carefully for just a second, and then I'm going to let you do your thing, okay? I'm going to have you work in partners. With your partner, the first thing that you need to do are 2 simulated experiments, okay? This is really good practice for the AP exam. We've been talking about this a lot, right? The whole game here is to ask questions, identify variables. I don't know why this is being so goofy. There we go. Identify variables and then do something with them. So you're going to ask a question, how does blank affect blank? For example, how does the angle affect the range? That would be an example. There are lots of options out there, okay? You're going to identify independent and dependent variables, and then you're going to collect data. So you're going to run trials or tests. You do not need to do multiple trials at the same angle because it's a computer and it's going to calculate the same number every time. So that would be a waste of your time, okay? But you're going to do 30 degrees and do 45 degrees, and it's probably going to be the farthest one, right? And then you're going to do 50 degrees and 60 degrees, and you're going to find out how it changes, okay? And then after you collect your data, you're going to graph it. There's graph paper right on the back of that pink sheet, okay? And then after you do that, you're going to draw a conclusion about your question from your graph, and you're going to support it with evidence from your graph. You with me here? Okay? You do that 2 times. Ask yourself 2 questions. Okay? You can come up with one, your friend can come up with one, but I want you to do them together. I don't want it to be like, all right, Courtney, you do this one and I'm going to do this one. Right? That's not what I'm intending here. After that, or tonight, depending on how long it takes you, I want you to set up 2 practice problems. Can you give me some more problems to do? Sure. There's like an infinite number there, right? So I want you to set up 2 problems. I want you to set up one that's got a horizontal launch to make sure you really know how to do horizontal launches. So that's boom, right? And then one that's at an angle, and you can do it up high, you can do it down low, it's up to you. Choose and set up the parameters, work through the problem, and then check it. Okay, does that make sense? You got this. This is just me so that I can grade this, okay? It's out of, like just the way that I did the points, it was out of 18, but that seems like a whole lot, so I'm actually going to grade it out of 9. So we'll grade it out of 18 and then divide by 2 to get your out of 9. Okay? Questions before you get started? You can pick your partner. I'm fine with that. Or if you really want to work by yourself, that's okay with me as well. All right? But I would like you to work in pairs. I would prefer that just so that you have access to it. Okay? Get started. Get going. Ask me questions if you have them.
I got it.
This is Carboon.
What's up?
So, rate